Hello, good morning. I'm Jessica. How are you today? I hope you always fine.
Hi, I'm Samir. Nice to meet you, Jessica. I'm gonna be okay today, thank you.
Today I will give a little explanation about modeling computer network to graph. Have you ever heard a little about this topic before?
I think I will hear from you now. Try to give a little discussion of it to me.
As we know that the computer system plays an important role in today's modern life, therefore we need to know what are the things that need to be understood to be able to operate a computer.
Okay, understood. Give me all the explanations.
In general, a computer is defined as a set of electronic devices that connect components with one another so as to produce information that has previously been processed. The computer consists of three elements, namely, hardware such as processor, hard drive, RAM, CPU, motherboard.
Then how do we find out how computers can communicate with each other?
As implied by the term, graph neural networks, the most essential component of GNN is a graph. A graph is a data structure in computer science that consists of two components. Vertices and envelopes G=V can be used to define a graph. Each vertex has an associated edge, E, that connects it to every other vertex, V. The phrase vertices and nodes are commonly used interchangeably, however, they are distinct concepts. A directed graph has arrows on its edges, which is referred to as directional dependence. If not, the graphs are undirected. A graph may be used to depict a variety of objects, including social media networks, city networks, and molecules. Consider the following graph, which depicts a city network. Cities are depicted as nodes, while the highways that link them are depicted as edges. We may use the graph network to solve a variety of issues relating to these cities, such as determining which cities are well connected or determining the shortest distance between two cities. When we build a graph model, we use the appropriate type of graph to capture the important features of the application. We illustrate this process using graph models of different types of computer networks. In all these graph models, the vertices represent data centers and the edges represent communication links. To model a computer network where we are only concerned whether two data centers are connected by a communications link, we use a simple graph. This is the appropriate type of graph when we only care whether two data centers are directly linked and not how many links there may be, and all communications links work in both directions. To model a computer network where we care about the number of links between data centers, we use a multigraph. To model a computer network with diagnostic links at data centers, we use a pseudograph, as loops are needed. To model a network with multiple one-way links, we use a directed multigraph. Note that we could use a directed graph without multiple edges if we only care San Francisco whether there is at least one link from a data center to another data center.
Okay, thank you for providing this material. I think I understand enough now about modeling computer network to graph.
You are welcome, Samir. Have a nice day and see you next time.